Hello, everyone. I'm just going to start doing the setup of things while we wait. So let me mute. Sorry for those of you that were watching the recording. We're just going over, we went over what we're doing for homework 6. We're looking at that the project 4 is due next week, not this week. And there, because we're also going to do the presentations in the lab. We meant to talk about this, and we're just reviewing what we did last time with how to manipulate our data. We're looking at faceting. All right, there we go. We're caught up. So a facet is, it's this stuff here. So we're going to look at 3 different types. Juxtaposing, as in I put 2 side by side, or a whole bunch of them. I may have a matrix, like a grid. We may have a grid of different views of the data. We can partition our data. That's a weird one. It's kind of, it gets in the weeds a little bit. If I partition my data, I show, let's say I'm showing grade point averages in the class on one side of a line, and on the other side, I'm showing number of homework submitted or something like that. So I'm showing the same data set, and only part of it's seeing, one attribute, the other part seeing another attribute. I'm partitioning my data and seeing 2 different views. And then there's superimposing, which is which you wouldn't even think of it as 2 different layers, but if I show one particular attribute as a data set, I show another set of the data as what, I'm showing, we'll see an example, but if I show all the countries from the Americas, North and South America, and then I show all the countries from Africa, and those are 2 different visualizations looking at gross domestic product and life expectancy, let's say. If I overlap them, if I show them on the same visualization, but just use 2 different encodings, I can convey a lot of information. Okay, that's what the superimposing is. And it's a combination of those things. The key is that you wouldn't think that that would be a big deal. It's like, oh, well, we're going to show 2 different types of data on one visualization, or we're going to show 2 different visualizations. But that makes a huge difference, because if I can link them together, I got more real estate and I don't get clutter. So here is faceting. It means to split things. I can split off a data based on our attribute. I can put 2 different attributes. I can show the same data from 2 different perspectives. And much like Dopey's eyes here, when lights goes in, it gets refracted. I'm looking at different perspectives of the same thing. I'm not looking like at different faces of the diamond when I look in. I'm not looking, it's not one uniform view. That's sort of what I want you to look at. It's examining things from multiple perspectives. So we've already went over that part as well, a little briefly, but a facet essentially it's many-sided, normally refers to gems, but what we're talking about is multiple views or multiple layers. And it reduces complexity, much like with your courses. Maybe you enjoy doing this now that we're doing online courses, that you might work on this class one week and then you work on another class another week. Or maybe your Tuesdays are always reserved for this class and then your Wednesdays are reserved for another class. You could facet your entire work habits this way. So you have one class dedicated, one day dedicated to a particular class, right? It reduces the complexity. On a Tuesday, I only work on 2100. I don't have this like, oh, and then I'm going to switch context, and like the context switch can kill you, or it can just be messy and muddled. When I clean my room, I organize things into bins, right? So here are 2 of the big ways. The partition way is the partition way is slightly different. So I can split my view. The partition does it at the same time, but it's sort of in the same image or just an invisible line in between. So I can do 2 different views, put them side by side. I don't get any power with that unless the person can connect between the 2 concepts. There is also the superimpose. I take the same data set, I change one of the looks of one of them, put them on top of each other again. And the easiest way would be to give an example. I'll give an example soon. Side by side is easy to compare. It takes up space. duh, right? If I have a matrix of these things, if I have like a 4x4 grid of visualizations, I don't have a big visualization. I got 16 of these things, right? It's going to take up a lot of space. So if I wanted to, if I have these two views, right? Here is African countries. Here is so African countries, and this is Americas, right? If I put the two together, this would be what the side-by-side view looks like. It's not as easy to directly compare, by the way. If you hadn't noticed, I have to go down here. But if I only want to look at, if I'm only comparing African nations one time, uh, and then I'm comparing American countries up here another time, and then sometimes I do a little bit of cross looking back and forth, this juxtaposition works wonderfully for that. If I'm trying to compare directly African nations and American nations, then I don't want to do a juxtaposition. It's actually harder to compare. They're separated vertically. And notice that alignment is a big deal. I mentioned this in a couple of, I can't remember which of the designs that I was looking at for this. There are sometimes when you have like a bar chart and another bar chart, but beneath it. If I have two bar charts and they're looking at similar data, but they're one is for, or I'm looking at two bar charts for two different attributes. So I'm looking at, oh, the red light cameras, I think it was what I was looking at for this, right? I might look at red light cameras, number of violations incurred, and maybe the amount of money, and then the number of violations and the number of red light cameras or whatever. I can't even remember what the other attribute was, but it was two different attributes, both using time stacked on top of each other. But they didn't include, if it was when the red light camera was put in and when the violations occurred, there was actually a little gap. And so everything was shifted over. The two axes were not aligned. If I'm going to, if I want to compare across, I want to align my axes. So if this thing starts in January, the other visualization below it starts in January. It ends on the same month too. So I can compare up and down and compare everything. If this started off with, let's say 500 instead of 200, right? They both start off with 200. They both start off actually with 0, right? They both start off on the same x-axis. If they started off on different axes or different amounts, if they were not perfectly aligned, I cannot do that direct comparison. So that's another part of what you're looking for. That to juxtapose it, I also need to make sure that they have a common axis so I can visually compare things. Small multiples, I don't get the same amount of direct comparison. I can't compare this to this easily, but small multiples, the term is been thrown around for a long time. It is give me essentially a whole bunch of little visualizations for everything. It's one of our bread and butter techniques. You'll see it all sorts of different places. I put a whole bunch of visualizations in like a grid-like pattern, and now I can compare multiple different attributes or multiple different data sets together at the same time, provided they're linked. So, well, I think I have the pedal, unless I've already showed that visualization. There's a bunch of classic visualizations for how you can show small multiples, but normally it'd be like a grid of different views, and when you change in one, it gets reflected everywhere. Multiform visualizations are a slightly different beast. I get the same data, different encoding, which seems, what? Why would you do that? So it's the data sets are exactly the same. I'm just viewing a different attribute. It is different. This one would be different data, same attribute. So I have income, life expectancy on all of these axes. This thing over here is I have the same data, different. I encode, so the data is the same. I encode it in a different way. So I'm trying to think of a good example of this. A lot of your systems may have the same data set from a different perspective. Even the same attributes are being shown, but one of them I'm doing it in this kind of visualization. I'm doing the same thing in another one. Or maybe I'm doing some combination of them. I have some of the attributes are in common between the two of them, but I have a different way of visualizing that same data set. Again, it's all just different perspectives of the data. If I see things from the same data from the same perspective, I'm wasting my time. An attribute has to change, a way of visualizing the data has to change, the data set has to change, some combination of those. If I'm superimposing a layer, it is I layer on top of each other, but it's really, there's really a lot of limits to my encoding method. I cannot do like 5 different layers at once. If anyone, if you want to pull out your iPhone, if you're an Apple user, I'm not, so I can't really show you this, right? Let's see if I have, no, I don't have it on mine. Try with your iPhone though. Pull down the menus option, the shade. What do you see? You see a frosted glass pane on top of a bunch of icons, which is on top of a background. All 3 layers work independently from each other. It's the interaction that tells you that these are 3 different layers. Notice Apple didn't try and put a 4th layer in there. It gets really messy really quickly. So 2 layers, fine. 3 layers, harder. 4, 5, 6 layers, no. You're in small multiples territory. Superimposing a layer is just, I have either a different data set or a different attribute that I'm visualizing, and I put it on top of the other one. Normally different data set. It is really easy to compare, but I have limited scalability. So it'd be something like this. So here's my small multiples version of it, and I just put them on top of each other. Notice it's a lot easier to compare African nations and American nations this way than this way. They're the same data set, here, but it doesn't really pop quite as much. But I put more crap in there and it's just going to get an unruly mess. Okay. And so a layer, it's sort of limited number of, they're limited. They're powerful because they're intuitive. People understand how layers work. You sort of, by any kind of movement, having independent attributes or independent ways of encoding the data, you automatically see layers. We're playing with their visual system. That's what we do. The Gestalt principles tell us that if you use a different color, people will see it differently. If you group it differently, people will see it differently. And we have a lot of other things. One of the things we can do, and this is, it sort of floats around with the, what do we call it? Oh, there's a proper term for it. The idea of only seeing one part with partition. There you go. I knew it was a P word. The partition approach. So I can choose one part of my view and do it differently. This thing keeps on falling. I can do one part of my view and add a layer to that view, or only see some of the data in that view. That's what for the partition approach, it is, I have a sub part of my visualization that it's going to show different data or different attribute than the other parts. A layer, I can have things like magic layer. You have an example. There you go. This would be examples of layering. So this would be one of our forms of layering. Your iPhone does. One of my favorite articles of all time, just because I snickered. And I think this is my former supervisor, now at Tableau Research. Her research paper was called Collaborative Coupling Over Tabletop Displays, which sounds dirty. I don't know why. I'm juvenile collaborative coupling. Yeah. But that's what they went with the title. So I love it as a title. The idea that they had for this experiment is they had people looking at a map in a city using what this is called a tabletop display. And they had what's called a magic lens. It is a window or a little area that you can move around. It is a perspective into the visualization that shows something different, like what a magnifying glass gives you, or if I put a colored piece of paper on top of something, right? It's a layer that I can move around, but it peers into it and sees something different. Superman's X-ray vision. There you go, right? It's a little window that you can move around and see things special. So in this case, it's a little window that they're moving around showing bus information. And they're asking people collaboratively work together to find a bus path from here to here, right? They need some task and how people work together. And what they're looking at is how people go about doing that task. They don't care about the visualization itself. They don't care about finding bus patterns. They really don't. They're looking at how people work together on a tabletop display. So, but this is just one example of a magic lens. The idea that you can put a layer, this little window, on top of your visualization, and you can move it around, and you see something different than everywhere else, versus trying to show everything all at once. So what I could have is, imagine if you have your Google Maps. I could have a Google map showing the terrain and a Google map lens showing uh, traffic. I could have another lens showing, um, think of example, snowfall or weather patterns or construction material. So the construction traffic group, you have a proper name for it. The communists. Sorry, you were one of the few groups that didn't change your name. So, communists. I can't pronounce it properly, but communist, but communist. Uh, they're trying to show multiple different pieces of information. A lens would be useful for that. Might be useful for that. You can't show both traffic information. It can be difficult to show both traffic information and commuting information and how many people are on the street and this and that and this and that. So instead, you could have a lens for one part showing traffic information and another lens that you can move around showing construction. I'm not actually asking you to do that, but just one option. And if you overlap them, you would see construction and commuting information, but it'd be really, really busy. But you can move these lenses around and see different perspectives of the data. This is where layering gets handy. I can do layering here, so I can see just, let's say, the skeletal system. And maybe my lens moves over this cadaver, and I just see the skeletal system. And I move the lens off, I move another one on, and I just see the musculature. Put the lenses together, and I see the musculature on top of the skeletal system. And we can combine these things. So I can have things like time. So this is actually moving over time. I can have all of these things at once. I can show so this is, I have a side-by-side partition. See what I'm showing is different. Income, life expectancy. Oh, there's just 2 different years. Here's 1884, here's 2012. I can compare across them, but I'm also having multiple layers. So all the different countries are in different colors. So I have all the different groups of countries as layers. Notice that's how I partition. I chose a particular attribute, like if they're from the Americas, Africa, Asia, which includes Australia, but I guess Oceania. Right? I combine these multiple layers and I can see them over time and I can show 1 year and another year and cross compare. We also have one other thing. So here, I can also, there's overview plus detail, and there's multiform and overview plus detail, but that's just overview plus detail. When we look at focus plus context, we're going to get into this. Sometimes I got too much data at once, and sometimes I want a different view because I want to see a zoomed in version of it. If you've played World of Warcraft, I think World of Warcraft does it. No, just Warcraft, not World of Warcraft. If you play Warcraft, you've played a lot of any of these real-time strategy games, you've seen this. Heck, if you've seen most any role-playing game, I think you end up seeing similar things to this. I have an overview of the entire world in one view, and then I have a much higher detail version in the large, the place where your characters are now. Rest the overview. So overview plus details, I get to choose a snippet of my data set, and I see that in high detail, but I still see the context. I still get the context of what I'm looking for. This is perhaps the better thing to look at. I'm gonna have to move something over here. So let's do this. Here we go. You notice you may think it's teleporting around, but if you grab this, if you go to this link yourself and play around with this, it will be obvious what's going on. I grab this, I move it around, and I see This linking with this, I have a linking between the two. I have an overview of what, let's say, stock market prices. I did one for, I think it was a currency exchange just before I moved to Canada. Actually, it was like my students didn't know I was moving to Canada. They're like, hey, let's compare the currency exchange between Canada and the United States. Literally, while we're doing this, I'm trying to find out if I can get my, uh, we're doing the currency exchange between the United States and Canada for buying our house here. Right. 'Cause that's one of our obsessions at the time, right? I can move this thing around and I'm seeing how things trend over time. You can look at GameStop stock market prices and see how it changed over time. Uh, GameStop stock price. Maybe we'll have another example of this. Oh, we have, but this is over the time. If I want, let's say 5 years, but notice I have this, the overview is, I don't have fine detail. If I have one day, it's really detailed, but I don't get the general trend. And I have to keep on changing these viewpoints. The previous version allowed me to choose a subset of my data. I can shrink the window that I'm looking at to a subset of my data, and I can move around the window. Okay. So this is focus plus context. I can focus in on one area. This is where I want to pay all my attention to, this big area, but I get the overview just to give me some context of where I am in the data space. Because if I don't get that window here, if I don't have this here, I will get lost. You've almost invariably, maybe you don't remember, but everybody has, somebody makes a system where you can move this around and they don't give you the control of how to move it back, and everybody gets lost eventually. That's what the context is for. Um, Here's brushing and linking. The idea is if I have multiple views simultaneously viewing, I can link them together and I can actually see what I'm doing in one, how it affects the other. So the other term that we're using, very, very important. What I will talk about brushing and linking with your projects for P4. If you have multiple views, I will talk about brushing and linking. It's so ingrained in who I am and what we do as a field that I just do it. It's powerful. It's important. So the idea is best described here is small multiples of, I mean, this is the ORCID data set, but whatever, it doesn't matter what the data set actually is. This just happens to be a famous data set. Somebody actually measured a bunch of orchids, but notice this would be the, there are 3 different types of orchids. They measured the stamen width and length and the steeple width and length, I do believe. But more importantly, this is stamen length, this is lumen length. And the depth, I don't know anything about orchids, but it's the same attribute in both axes. So you get a perfect line, because of course you get a perfect line. It's the same data. On this axis here is the exact same data as on this axis here. This shows me all the combinations of 4 different attributes. So same and same, one attribute and another attribute, one attribute and another attribute, one attribute and another attribute. So along the diagonal, we should get the exact same thing. In fact, for a small multiples, we only need this side over here because this is exactly mirror image of the other one. Okay, but here's the important part. Let's move that around. Let's shrink it just a little bit. Okay, and let's move this up here maybe. Maybe we want this. Or maybe what I could do is instead of that, I could like that, for example. Oh, I caught a whole bunch of greens and blues, oranges and blues in there, right? Maybe I'll put this up. But you can start seeing, maybe it's not as obvious in this case, but you can start seeing how things are related. The selection over here selects the other stuff in all the other views. And I can see how all the blue, so these are Adelie orchids, how they are related with amongst all these different attributes. Since we don't know, I'm assuming, know much about orchids, maybe that one is not as obvious. Let's do another one. This is actually from Northeastern. I found this just before teaching this lecture a long time ago. This refugee scholars in the Nazi era. The U.S. had a rather alarming, well, maybe not alarming if you know anything about the U.S. history, but uh, Canadian history, same thing, history in general, but alarmingly racist past when it comes to admitting people into a country. And so they had a quota system where the number of immigrants you could take in were based off the number of immigrants that were already in the country. So essentially making it so that British people could move into America, but not a lot of other groups could, uh, unless they're being killed or sent off to war, that sort of thing. They were all for immigrating people then. Um, but here is a bunch of different countries. Then I can turn off France. Let's say, let's put France back in. Let's put in the UK. This is their quota, what they were allowed to take in. This is the number of people that were actually trying to get into the country. This is the quota that they're allowed to take in from Italy. This is the number of people that moved into the country. And if I'm selecting one, it changes the view and the other views. This is all I was trying to point out from this. This allows me to select in one and you'll see it reflected everywhere else. The interesting thing about this is non-quota immigrants admitted under the Immigration Act from 1924 to 1924, 1913 to 1949, and so right about 1920. Well, it's actually showing the full thing, but this 1926 onwards, if you look at this, the number of people coming in as a student shoots up as a result. It's one of those weird people learning to exploit systems and figure out how to work through whatever regulations people put into a country. But you can even look at how Germany, immigration works for Germany. You can look at it over time as well. Oh, there we go. Brushing and linking. And you can move things around and you see what, because you have this linking between all these different views, you can see why doing one affects the other. It's a very powerful technique. Even if you don't believe me right now, it is shockingly powerful when it's done right. Oh, nice. Got a bunch of things here. Um, oh, penguins. Really? They must have changed it. It used to be the Orchid data set. So I was just going off of my brain, off of memory. I'm like, it doesn't look like Stamen. Begin to, of course, I've been watching Atypical about this. Of course, and chinstrap penguins. You're right. So when did they change that? They used to have, it used to be the Orchid data set. I'm sorry. Thank you very much, Tori. Yes, they're all penguins. The length and the width of their bill. Oh my God, nice. Thank you. Um, it didn't. It was to the point that it didn't matter. Uh, I can show the technique without even knowing what the data set is. But yes, these are all penguin types of penguins. Only 3 types. There's more than that, but um, just because I did it for H4 and I was confused. Nice. Um, I think I'm really surprised. I think the Orca data set's a better visualization in my books, but yes, they published it. It changed from what I originally used. The original one was the Orchid data set. I don't know why he changed it, but okay. I like this one more, probably because it comes from Northeastern. Uh, and you can see how things, I just think that's cool how you can change it over time. Okay. I want to show a quick video. It'll let me rest my voice. It'll also maybe actually I'll put you to sleep even more than my lectures do. Uh, John Tukey, though, has one of the great accents. It was like, why does that accent sound like he's from down the street? Oh, wait, because he is. He's a fun little accent. John Tukey, though, is one of the most important statisticians, I think, ever. He's up there, and he's relatively new. Uh, he's sort of this conical figure in visualization as well, because he comes up with half this stuff. He's the first person to use the term software, one of the first people to use the term bit. Honest to God, like he's been around for a while, but he was right there at the dawn of computer science and dawn of computing. And on top of that, he's there, but at the time, he's a statistician. He's not a computer scientist at all. He's not a programmer. He's not a he's a computer science that comes from mathematics, but mathematicians normally. He's not a mathematician either. He's a statistician. And the weird thing is, everyone at the time, he was fighting against statistics for God knows how long. There's some great lectures on Tukey. This comes from Stanford. There's a great talk from Jeffrey here. When he moved to Stanford, when he started work at Stanford, he gave a lecture on statistics and visualization. And he's pointing out the history of Tukey and this particular project that we're going to look at. He's arguably the father of interactive visualizations. He shows brushing and linking before anyone else does. He develops brushing and linking for the first time. And from my perspective, I love Tukey I hated the Tukey test and all these other things that he came up with all these tests in his name. He's incredibly influential. But while everyone else takes a bunch of data, crunches numbers, and throws out data and just says, yep, that's what it says, Tukey is fighting against other statisticians who are just crunching a number and coming to conclusions based on the statistics. His view has always been you need to look at the data first before you run a stats test. Because if you don't, you're going to get it wrong. You're blindly guessing. It's my fight against machine learning, right? As well. If you just blindly crunch numbers, you're going to come to the wrong conclusions. Because just because there's a correlation doesn't mean there's a causation. Just because there's some kind of weird correlation doesn't mean there's some other interaction effect or something else is happening. You have to explore the data, then do your analysis. Because if you don't, if you just crunch numbers and hope to God you get some magic number that pops out at the end, it's probably going to be wrong. Exploration is a key part of the statistical analysis process and the visualization process. So this is John Tukey. I'm hoping my sound comes. Let me know if you don't hear anything. We're going to look at the parts at 2 minutes to 7 minutes and 22 to 25, 22, 25 to 25 minutes. Okay, that's the hope and the dream at least. So 2 to 7 and 22, 25. It is old school. Yeah, that music. Oh, I need to show that though.
For Implement 9 is an interactive data display system for exploratory multivariate data analysis.
Okay.
Developed at the Graphic for implementation and programming, Marianne Fisher-Keller. They were aided at critical junctures by 3 advisors. In particle physics and production, Jerome H. Friedman.
No, that's a badass haircut.
Stephen Levine. In editing and sound recording,
and a very bad mustache. All right. I had to show that.
Prim 9 has been developed toward ends of very different breadth and distance. First, to learn more about what we can learn by looking at the numerical aspects of data in more than 2 aspects at a time. Second, gaining a tool for pictorial examination and dissection of particle physics data, especially data involving several body final states. Prim 9 has grown through many stages, but the evolution of display systems, like the evolution of animals, is a branching process. And so some of the abilities that are vestigial in Prim 9 may later turn out to be central for other display systems. Prim 9's emphasis is on picturing and rotation on the one hand and on masking and isolation on the other. Picturing and rotation is an essential ability, valuable alone. But the usefulness of this ability is greatly enhanced when it is combined with masking and isolation. For us, picturing means an ability to look at the data from several different directions. Rotation means, as a minimum, the ability to turn the data so that we can look at it from any direction which we choose. For picturing, Prim 9 offers us the choice of any two of the current coordinates as horizontal and vertical axes, two buttons cycling through the choices. One button interchanges the coordinates shown on the vertical direction. The other button interchanges the coordinates shown on the horizontal direction. In that way, it is easy to go from showing variables 2 and 1 to 3 and 1 to 3 and 2. Since the data we are showing at the beginning is only three-dimensional, these are the only three views that we need. Just being able to see projections on all coordinate pairs can, as we have just seen, be very helpful, but it is not enough. To be able to get reasonably to all two-dimensional projections means either a way to call for what we want or a way to move about. Since we usually do not know just what we want, and when we do, we would find it hard to learn to call for it, what we need is a way to move about. Rotations are natural movements, but which ones? We have settled for only those interrelating a pair of the current coordinate axes. A simple example rotates coordinates 1 and 2 while keeping coordinates 3, 4, and so on fixed. If we look at the 1-2 plane, it looks like this. First forward, and then backward. If instead we rotate between coordinates 3 and 1 while still looking at the 1-2 plane, it looks like this. First in one direction, and then in the other. Here an invisible coordinate is being rotated against one visible one. Finally, if we rotate coordinates 3 and 4 while continuing to look at the 1-2 plane, we see no change because coordinates 1, 2, 5, 6, 7, and 8 are all being held fixed. The control of rotation is by 3 buttons, 2 of which choose the coordinates to be rotated between, while the third one drives the rotation alternately in one, because we could look at these parts separately. Prim 9 is now ready to examine and dissect particle physics data. Its direct value for this purpose will have to be learned by experience. What have we learned from its development beyond a reasoned conviction that pictorial systems, to be effective, must go through many stages of trial and error learning as it did? What have we learned that will be useful at other locations? We now understand that the details of control can make or break such a system. We now recognize that these details of control must be adapted to what is available and to the people who are to use the system. If we had had 10 knobs and 6 switches instead of 32 buttons and a light pen, we could and would have realized the same 4 essentials in a quite different way. We now recognize the great value of such dynamic aspects of the display, especially easily recognizable rotation. 2 aspects, horizontal and vertical, are always before us. What third aspect supports them best? We now have a strong feeling, almost but not quite a conviction, that the dynamic aspects of rotation are extremely valuable, more useful than stereoscopy, color, flicker, or distinctive characters. we have learned that this sort of pictorial facility can be useful in two quite different ways. First, directly, and second, as a source of ideas and approaches. Ideas and approaches that can guide algorithms for experimental programs to chew over numerical data in a batch mode. The first of these chewing over programs is now in an advanced state of development. Others can be expected to follow. Finally, and above all, we have learned that the four essentials of picturing, rotation, isolation, and masking need to work together, and that from them we can learn much.
Oh, and turn around and just ignore the camera now. I love that ending. I'm just going to go back to work. Here you guys. Ooh. Okay. Let me point out something, though. In case you're wondering why, end of file. I don't know if anyone's quite appreciating what this is. I used to show the mother of all demos to my HCI class back in the day. The mother of all demos from Doug Engelbart. And you'll see it, and he's talking about the mouse, and he's like, I don't know why we call it a mouse. We just did it. Just sort of start. It's boring as heck. It's all in black and white, and everyone's like, oh my God, you're killing me. And then I go, okay, so what year is this? And why is he talking about the mouse? And they go, I don't know, he just boring demo. And I'm like, yeah, he invented the mouse. No one had ever seen a mouse before in this thing. He showed like 8 different revolutionary technologies in this, like, I think it's an hour-long video, but you can literally just see these massive technologies that no one appreciated at the time. But then when, I think Steve Jobs was one of the people that really just went, no. He went to Xerox PARC, looked at it and went, holy crap, and stole it, essentially. Didn't actually steal it. He actually paid for it. But when people see what the actual benefit is, you were not expected to know what he was talking about with rotation on the y-axis, and without conviction, why this is going a certain way. We're not talking about that. We're not expecting you to necessarily follow all parts of that, what he's talking about. But notice what his takeaway is. In 1973, this is before I was born. That's how old this video is. And in 1973, before they have a graphic user interface, before they have a mouse that's in everywhere, the mouse was not popularized until the 1980s. Right? This is 73. They didn't have graphic user interfaces. They didn't actually have the GUI yet. They did some experimental work in it. The mouse was invented beforehand, but no one was really using it. It wasn't Stanford, but he wasn't using it. This guy is doing 3-dimensional plots that are interactive. That is crazy, with different perspectives, with brushing and linking he ends up throwing in there as well. And his first thing after he's done this is he goes, holy crap, that's more important than color. It's more important than stereoscopy, being able to see with both eyes and see 2 different views. More important than all this other stuff, the ability to explore data comes from the ability to interact with data. If you want to know more, you end up playing with it. That's how you learn things. It makes it very hard to do correctly, but it becomes incredibly powerful, seeing multiple perspectives, multiple views, multiple slices of the data, and then interacting with it. It is the sea change when it comes to statistical analysis. It's the change in how we look at things. So if you think we're just doing pie charts or bar charts and stuff like that in this class, this 73, you're grossly mistaken, because the power doesn't come from just here's a static image. No, the interactivity is where you get all the power from. If you want it immediately obvious, you could still throw in some interactivity. It doesn't have to be there. But any kind of exploration, any kind of discovery, that's where the power is. It's in the ability to interact. And it's really hard to do correctly. But John Tukey is doing it in 73. So if you think the coding here is difficult, you have no idea what this guy must have gone through. Actually, kill Killfisher or whatever her name was. I think she was the programmer for this system. Okay. Here's one of my favorite Tukey quotes. So, the greatest value of a picture is when it forces us to notice what we never expected to see. If you go looking for what you expect, you're going to find it. But that's not where the power comes in. Power comes in when you surprise people. There was one of your, let me think, I think it was the Green Monster group, where we had some really cool thing of like the amount of energy being used by everyone is single family homes is really disproportionately using way more power than everyone else. Now, it might be also the vast majority of people living in Canada, and therefore it's not proportionate. There's a statistical flaw in there. But if it holds out, then that's a huge thing. And if you get users to find that anomaly, it can change behavior. If people, you can't, you if you tell them, they're not going, whatever, or I don't believe you. If they find it themselves, they will internalize it. Getting people to explore data lets them find things that they didn't know beforehand and really can change behavior. Okay. So I want to do an in-class exercise. We have time. So here is, in case you're wondering if you think your exercise or your project is too badass and oh my god, no one would ever expect something like this from other teams. This is actually, I think it's still up, hopefully it's still up and running. This was a visualization project for another class. I think from not even from Northeastern. It's not even from Harvard. It's from one of the other universities in Boston. Um, they had access to the MBTA, the Metro Boston Transit Authority, MBTA. We call it the T. We don't have this in Ottawa because the O doesn't run. The light rail train in here, the tracks would just be like, it's not running, or 4-hour wait. But here is what the subway system looks like in Boston. I would love to do it for Ottawa. I just don't have access to the data. You can play around with this. And what I'm going to ask you to do is, what interaction design principles are being used? What are they looking at? Are they changing over time? Are they looking at selection, navigation? Are you zooming? Are you panning the data? Are you constraining the data set? Are you looking at particular slices of the data? Are you cutting the data? So a slice would be, I am choosing a particular attribute and only seeing that one attribute. A cut is, I'm going to select this group and only look at that. So this is remove everything but the thing I'm looking for. This is cutting away other stuff. They sound related, but yeah, and I'm not going to be overly picky about this. Maybe it's projection. Maybe I'm only looking at some of the data. What parts of Schneiderman's mantra of overview, zoom and filter, and details on demand? So overview gives me the general view of things. Zooming in, I choose a subset. Details on demand, do I see that at all? And which of these are your favorite visualizations? How do you think you could improve it? So we're going to throw this in the Google Drive folder for lecture 11. The Drive folder again is on CU Learn, but go to the MBTA viz. Let's make sure it's up and running. There we go. It is up and running. Good. I forgot to check that beforehand. And have a look at what we have. By the way, this is the red line going down here, branching off. This is the blue line. This is the orange line. This is actually I started here. I'll go to here, right? Let's see if that's, I think it is. Tufts Medical, Chinatown. It should be. Why isn't it showing? Mass Ave, Ruggles. There's my old subway stop. So I go from here to here every single morning and go back every single night. That was my path. It was on the orange line all this way. But what do you see? Can you make head or tails out of this thing? And how about, here's all the various places, the start of the subway line, the end of the subway line here, and then going back afterwards. And this is to clarify things beforehand. What they actually have was when you scan into the subway, they don't know where you get off on the other end, but they know when people go in. They don't know where they're going, but they know the entrances that people go into a subway for. And so they can check, they have the count for how many people swiped a card or paid to get into the subway system at various times of the day. So at 8 o'clock in the morning, 8 to 5 in the morning, 10:30 in the morning, and how this changes over time. Oh, and you also know when someone leaves a subway station, but you can't put where they're going to where they're going. They just know when you leave, the door opens. Okay, so your job is to look at all these things and see which one you like the most, which one you thought works well, what kind of interactivity do they have, that sort of thing. Okay, so I will leave up the set of instructions here. You'll go to lecture 11, but explore the MBTA visualizations and see what you think. Okay, and I'm going to finish more of my coffee. If you're confused by the instructions or don't know what you're supposed to be doing, please ask, by the way. I don't want people sitting in silence and hoping I don't notice. So we're only going to take about 5-10 minutes. Just make a document, throw in a bunch of, think about what you're seeing, maybe explore a bit. Let's say 10 minutes. Because I want you to get a feel for what we're talking about here and applying what we just learned. Okay, I'm hoping you had a chance to explore around the data set right now. In the next less than 5 minutes, can you write up whatever you want? I have nothing right now in the folder, so I just want to make sure we don't run out of time for the other stuff I wanted to cover today. Okay. It is 9:43. I wanted to give at most 2 more minutes. So therefore, I should start seeing, hopefully, some new files. I would assume that people would have made a new file and put it in the folder right away and then filled in the file afterwards. And right now, I've seen nothing in the Lecture 11 folder. If people are not doing it at all, just letting you know, I'm going to start turning off some of these things. Oh, um, what are you uploading though? Are you doing a full doc? I was assuming like a Google Doc that you just edit it on the file. Okay, that's going to take a bit longer to do. If you do a Google Doc and you can just drop images in it, then it just you doing it on the fly. But then I start looking at what you're doing while you're doing it, I suppose. But I can also just, I'll wait a little bit more time, just try and upload what you can. Don't worry if your upload speed is horrible, that's fine, we'll work around it. But at the same time, I want to make sure people are actually doing it. I'm also going to turn off some of the other previous assignments. I've not been very good for that, but I'm going to be turning them off today, just letting you know. Okay. I'm going to start talking about this because I'm afraid of running out of time. And don't worry if I'll monitor this because I wanted to go over your solutions, but if we can't, I'll just go over a couple of them. Here's what we had beforehand. So what are we looking at? Interactive design principles, and we're overview, zoom, filter, details on demand. Okay. Hey, there you go. I got cars. Thank you. The rest include the map. Hovering over any data point or value is very useful. Yep. And so visualization, you can select a point to isolate and select a time. Yep. Each video shows an overview of the first data. Okay. I'm going to not embarrass YouTube. It's actually really good answers, by the way. Just it's all we're just dealing with a whole bunch of text right now. Let's pop this up and talk it through while all the other files are uploaded. So what do we have here? This is actually an overview. We have details on demand. I move over and it says what time it is. And it also shows me the exact timestamp at any given time. By the way, if I go along this particular line, we can see what train, this is all the different trains as they go over time. So as I move down this thing, you can see how the train is moving at any given time slice. These are all the trains on the tracks at, going on the MBTA system. It gives you the exact snippet of time for all of these different trains, and I get the details about the task itself on demand when I move my mouse over it. On top of that, let's see if can I do this? Yep, there you go. Here is that particular train throughout the entire day, actually, or for that entire run. From here to here, start there. I could choose this train over here, and I'll get this particular path. By the way, they have an annotated visualization here. So they're showing that there was a disabled train causing delays. And that's why all of these things were backed up as a result, which is very common. It was less common than it is in Ottawa, it seems, but this is after all the trains stop. And I might move around a train at night, but essentially all the trains stop at around this time and you're walking home at that point. I love this one. This one, what kind of thing do we have here? Well, let's see if can I expand these? Oh, this one gives me the expansion. Boom. Details on demand, overview plus, and then no details. And I can actually see where I am, this is Harvard Station or Harvard Station at various times. This is a more interesting one though. This is Alewife. It's the start of a line. Notice what we actually, or South Station is a big one as well. Notice there's this huge, the red is actually popping, has a pop out effect for really, really bad times. What places have that pop out effect? South Station. What's going on in South Station? If you know anything about Boston, which I'm assuming you don't, it's actually where all the trains get off. There's commuter rails that all land in South Station, and then you take the T to your work. So everyone takes a commuter rail into town, gets off there, gets on the train, on the subway, and goes to their work, or maybe walks. But that's actually where everyone's jumping in at the same time. Downtown crossing, huge thing, because everyone's working in the downtown area, and you get on the train there and you go off to your respective places. But notice it's only one direction, one time of day, the end of the day. Because at downtown crossing, you're leaving work and going back to your house. Your house could be anywhere, but that's the entry point. If you're looking at Harvard, let me see here. Alewife is a good one. Alewife, notice the banding. It's only first thing in the morning because you commute in, you drive into that place. It's the end of the line. You drive in, you park your car, get there, and then and when people leave at the end of the day, it sort of tapers off. It's almost any time. But the entry point, this is a commute into work. And you can actually see when not to go to downtown crossing. Whatever you do whatever you do, no matter what week you're looking at, you never enter downtown crossing between 4 and 7 p.m. You will drive yourself mad. The takeaways: when not to go to downtown crossing. You can all sorts of, so this is 82 people per minute going through the turnstiles. And look at these other things. No one's going in and out of these things, or very rarely. But downtown crossing has this steady stream of people going in. Harvard also has these bands of time. Let me see here. We have the amount of congestion and the amount of delay on the various lines over time. And you can see that in this visualization. All of which are, you get an overview, and then you get some details on demand afterwards. And you can zoom in and select your data. You have color being used for pop-out effects in here. You have interaction. I should be able to select, let me see if I can select individual things. Select, I don't know if I can highlight a certain area. I can't brush and link. I can't brush, at least I can select and link. All right, so they're missing that particular thing, but this is still pretty phenomenal visualization for, given that it's a school project, a course project. Okay, yes, it was a course project. So just to give you some perspective in this thing, if I'm coding the same data with the same perspective, I'm showing all the data, so not just a subset of the data, but all the data, and from the same way of encoding it, it's redundant. I have the exact same visualization twice. But if I have no shared data and the encoding is completely different, they're not related at all, and it's not brushing and linking anything. They're just completely independent visualizations. Everything else, I have different ways of slicing this apart. So if I have none of the data is shared, but it's using the same encoding, it's called small multiples. So I'll have this type of data or this attribute, but not in the other cases. If I have different ways of encoding the data, but as a subset of the data, I'll have multiform and overview plus detail. Multiform is I have two different ways of encoding the exact same data set. And the way I slice and dice this thing, you're thinking about this from different perspectives, but you all have to be sort of looking at the same data set. The power of interactivity is if I see two different perspectives and there's something in common, I can come to conclusions, and I can think about or look at more data than just trying to pack everything all at once. The big thing that everyone does at first when they're learning how to make a visualization is they try and put too much on the screen at once, or they're trying to pack in too much into one single visualization, or in some cases, too little. There's a fine line, and interactivity and faceting allows you to do a whole lot more data than you would be able to get onto a single visualization. So we have highlighting. So I'm selecting this group. Brushing is the act of selecting this group. Brushing and highlighting is me making the selection. Brushing, highlighting, and linking. So brushing and linking is I highlight in one and it shows up in the other visualization. So when I select this data set, it selects all the bars in the other data set. This used to be very critical because the course project required everyone to have brushing and linking in their visualization. You don't need it, but it's highly recommended. Brushing and linking gives you a power that you can't get otherwise. So I select in one and it shows up and is reflected in all the other visualizations. So if I have multiple different views of, let's say I have my COVID cases, right? I'm looking at the map, I'm looking at COVID cases. I select these 3 hospitals where I can get a COVID test, and it shows me the associated data in the view of COVID cases in the city, or if they're connected together. Or maybe it's the number of, I select these hospitals, and in the visualization of number of COVID tests that they do per hour, not based on the map, but number of COVID case tests they can do per hour, or the amount of congestion in these various centers. Those 3 places would be highlighted in that visualization. The link between these 2 different these 2 different visualizations, gives you a power that you can't get otherwise. It does take time and effort to do. And by the way, partitioning of views, split the data into meaningful groups, either by key or the value. So I could say the attribute that I'm looking for, or based off of what data I'm looking at. And by partitioning my view, I can split the data. I can order the way that things are split, and essentially it's data driven. So I don't think I have time for this one. We're going to pick this up next time around. But let me point out or foreshadow what we're going to do. I want you to partake that string and partition it, group the text any way you want. The different ways you can break apart this line of text. The hello class, this is an example. How many ways can I partition this thing in different ways? And sort of the people that can partition it the most different ways wins. Wins what? Nothing. But, still impressive. That's what we're going to pick up next time, how I can break apart and partition sets. Then we're going to look at storytelling, and we're also going to look at maps. It'll be a fun time this Thursday. All right. Thanks, everyone. I have office hours now. I'm just going to grab a quick snack, but then I'll have my office hours. And you can ask me about your projects or whatever the case is. I can stay on the Zoom call if you want. Let's do that, actually. I'll restart the Zoom meeting again. I'll turn off the recording. So I'll pause it right now, but if you can take off anytime you want now, but I'll just stay on here. All right, thanks everyone.